Akwaba to the math classroom. If you have not seen a video yet on exact differential equation, you should look at it because in our previous lesson we explained what that is. Our lesson today, we are looking at an example of solving an exact differential equation. So we have our differential equation of a differential form, and of the differential form, this is what our m and this is what our n. And we said to check if it's exact, then the partial derivative of m with respect to y should be equal to the partial derivative of n with respect to what? X. So this becomes what? An exact ordinary differential equation. That is ODE, ordinary differential equation. So from here, in our previous lesson, if you've not seen the video yet, kindly find the link in the description. You have m to be equal to 1 minus what? 2x what? Y. So the partial derivative of m with respect to y here is going to be what? This is a constant, so it goes to 0. So I have minus what? 2x. Then if you take n is going to be what? 4y cubed minus what? X squared. So that the partial derivative of n with respect to x is going to be equal to what? Minus what? 2x as well, because this will go to what? 0. So you realize that this is what's equal to that. So then the differential equation I'm looking at is what? Exact. And if it's exact, then I can solve for that. So we know from here, you realize that my m here, so let me write it out here again. M is equal to 1 minus 2x y. Then I have n to be equal to 4y cubed minus what? Our x what? Squared. So to solve for the differential, one way I can look at it is to integrate this with respect to what? X. So I integrate my m of x, y with respect to what? X. And in doing that, what do I have? You realize I'm going to have the integral 1 minus what? 2x y the what? X. And this is going to be equal to what? If I integrate using the sum rule, then this is going to be x minus integrate this with respect to x, because y is a constant. I mean, y will be maintained. So integrating this is going to be x squared over what? 2. So let's say I have x squared over 2. So 2 will cancel out, so that I have what? X squared, then y plus a constant. But this time, because we are integrating with respect to x, our constant is going to be a function of what? Y. So let's say this is what? The constant, which is a function of what? Y. Then I can also integrate the n parts with respect to y. So I have n xy the word y, which is going to be equal to the integral of what? 4y cubed minus what? X squared the word y. So use your sum rule. What do you have? You realize that this is going to give you y to the power 4 minus what? X squared y plus a constant. And this time, this constant, because we are integrating with respect to y, then our constant is going to be a function of what? X. Okay, so one way to look at this is we could compare this differential, the integral form. If you compare, what do you realize? You realize that I have what? This is here. I have that, then I have this, and what? That as well. So that if I want to find the solution, my final solution, which is a function, so our solution, let's say f of x, y is going to be equal to what? My x squared, my x plus my y raised to the power 4 here, or minus that. So I have this and that here, so I have this and that, so I add onto that. That is x squared y. So this becomes the solution of the differential form. That is if it is what? Exact. That is one way to look at the differential words equation. So in our next lesson, we'll take another example on solving words, the exact words differential equation in another way. So don't miss our next lecture on solving more examples of words, the exact differential equation. Thank you, and don't forget to subscribe if you are new to my channel. Bye.